So we'll be going over briefly the difference between scale drawings, models. We'll learn how to interpret scale models and continue to use scale factors and proportions to solve real problems. To start, they tell you the scale on this map is 0.4 inches to 40 miles. We're asked to find the actual distance from Nashville to Memphis. So using a ruler, we're going to use the inches side and measure from Nashville to Memphis. It's approximately 1, 2.5 inches. So Nashville to Memphis is 2.5 inches. We know the scale is 0.4 inches to 40 miles. So using a proportion, we can figure out how many miles should be in 2.5 inches. Some cross multiplication will give us x equaling 250 miles. So using the map, we can scale everything up and figure out the actual distance to be 250. Same process with Chattanooga. Nashville to Chattanooga is just about 1.5 inches. Again, we know the scales have to be the same. So 1.5 inches to wherever the actual mileage is has to be the same ratio as 0.4 inches to 40 miles. Cross multiplication again will let you solve for y and get 150 miles. Now we've been doing a lot of problems like this, and we've been using a lot of scale factors and a lot of scale models. So we're going to keep talking about that. Scale model, so we all have the same definition, is an object or drawing whose lengths are proportional to the real thing. So corresponding parts will still be proportional, meaning you will still have a common scale factor. Which brings us to our next two words, scale versus scale factor. Scale is a ratio of the model to the real thing. And it must be in that order. Model first, then the real thing. Scale factor is a unitless ratio in simplest form. Again, with the model first. So we've been using scale factors a lot, and every time we have a scale factor, there's never been a unit to go along with it. So if you look at this example, this is a miniature replica of the Packard cab. The length of the model is 6.5 inches, and the actual length of the car is 13 feet. We want to figure out what's the scale factor. Based on this specific order for the scale, we need to do the model to the actual. The model is 6.5 inches to the actual, which is 13 feet. Well, 13 feet is the same thing as 156 inches. So we have 6.5 inches to 156 inches. Our inches cancel out, making this a unitless. And we get 1 to 24 after some simplification. We can flip to the next page. And now think about enlarging versus shrinking. We want to figure out how can the scale factor tell you if your model is larger or smaller than the original. Well, we always have the model versus the actual for the scale. That's what we're going to use now. Two things can happen. This number, this ratio, can be larger than 1, which means the model is larger. The scale factor could be less than 1, and the model is smaller. We go back to our car question. How many times as long as the actual car is the model? Well, the model is 1/24 the length of the actual. That means 24 models equal 1 actual. Now we have to decide on an appropriate scale factor in the next section. So we want to build a model of the St. Louis Gateway Arch. It's no more than 11 inches tall. We need to choose an appropriate scale and determine the height. So they tell you that the Gateway Arch is the tallest national monument. It's 630 feet. The span of the base is also 630 feet, and it weighs over 17,000 tons, weighs 9 inches in each direction during the wind. What we want to do to figure out what the scale factor could be is we need to figure out how many inches, since we need 11 inches total, will fit in the 630 feet. So we want 630 feet to 11 inches. That gives us 57.3 feet per inch. So that's the smallest possible scale we could use. We don't want to work with that decimal though, so let's round up the nearest whole number. Let's use a scale of 1 inch to represent 60 feet. So if we're using 1 inch to 60 feet, then our actual model, we can figure out how high the actual model should be. So x is 630 feet. We can cross multiply, solve for x. And x should be 10.5 inches. So the model you want to use, the appropriate scale, is 10.5 inches tall. Looking to the next example, we're going to do the same thing and try and find an appropriate scale. The room she wants to draw on is 8.5 by 11 inches, but her actual room is 14 feet by 12 feet. So let's take both of the corresponding parts. The 8.5 corresponds to the 14. No, I'm sorry. The smaller numbers correspond and the bigger numbers correspond. So 8.5 corresponds with 12. And that gives us 1.4 feet per inch. But then 14 divided by 11 gives us 1.3 feet per inch. So they're not the same, but remember, these are the smallest numbers. Since 1.3 is smaller than 1.4, we're going to have to go a little bit bigger. Let's pick a nice one to work with. We use 1 inch equals 1.5 feet. So if we use 1 inch to 1.5 feet, that means x inches should match with 12 feet. Same thing, 1 inch to 1.5 feet should correspond with y inches to 14 feet. Solving for both of those gives us 8 inches here and 9 1/3 inches down here. So the appropriate scale, this is the appropriate scale that we picked based on this information. We chose this though. The next page is actually your homework. So I'm not going to do this for you. This is what you are going to do and come back in with tomorrow and any questions. Good luck.